All right, prime factorization. We want to take a number and break it down into all of the smallest numbers we can that when multiplied together give us that value. So if I had 6 factors to 2 times 3. 8, if I factor out a 2, I'm left with a 4, and 4 factors to 2 times 2. If I did 36 factors to 2, and when I divide 36 by 2, I get 18, and then 18 divided by 2 is 9. 9 is 3 and 3. So 2 times 2 times 3 times 3, that's my factorization. For the way we're going to be dealing with these numbers, if you have something like, let's say 256. A lot of people will do something like they'll split that into, so that's 16 times 16, and then 16 is 4 times 4, and 4 times 4, and then 2 times 2 times 2 times 2 times 2 times 2 times 2. I find this to be more confusing when you're trying to break out bigger pieces. So what I prefer to do is always pull out all the 2's, then all the 3's, then all the 4's are already gone because 4 is all 2's. Then I pull out the 5's, and then 6 is gone because it's 2 times 3, and we already pulled those out. 2 times 2. 7's. 8 is gone because 8 is 2 times 2 times 2, and we've already pulled 2's out. And then 9 is also gone because that's 3 times 3. So let's see how this looks with something like 256. And then the other rule I guess I should include is we'll say divide. We put the divided out on one side and the remainder on the other. So if I divide out a 2, I'm left with 256 divided by 2, which is 128. Then I pull out 2, and I'm left with 64. Pull out 2, left with 32. Pull out a 2, left 16. Pull out a 2, left with 8. That was a terrible 8. Who drew that 8? Pull out a 2, left with a 4, 2, and 2. And so now these are my prime factorization. So let's try another one. 180. It's even, so I'll pull out a 2, left with 90. 90 is even, pull out a 2, and I'm left with 45. 45 is not even, so I'd go to my next 3, 5, 6, 7, 8, 9. And if you want to check if a number divides by 3, well, 4 plus 5 is 9, and 9 divides by 3. So 1, 1, 4, that's 1 plus 1 plus 4, which is 6, so 114 divides by 3. So if I divide 45 by 3, I get 15. 5 plus 1 is 6, so I can pull out a 3 again, and I'm left with 5. When you're done with your list, go back and plug this back into the calculator to make sure it works. 2 times 2 times 3 times 5 gives me 60. Why did that give me 60? Because I dropped one of them. So 2 times 2 times 3 times 3 times 5 gives me back to the 180 as I was looking for. If you want to see a list of values that divide, here's a list of rules here. Divisible by 2 if it's even. If it's the sum is divisible by 3, which is what we were just talking about, right? So 3 plus 1 is 4, plus 5 is 9. 9 divides, so by 3, so 315 divides by 3. So the rules, if you pull the values out in order, you only need 2, 3, 4 you already have passed, 5 you need, but there shouldn't be zeros, there should only be end in 5. 6 is, nope, 6 is gone, because 6 is 2 and 3, 9 is gone, 10 is gone, right? So really the only other one you have is 7. So if you don't have a rule like we don't for 7, or if you don't remember the rule, just plug it in. If you've got, I don't know, 504, if you divide that by 7, it equals 72. So if it works. If I did 508, divide that by 7, depending on the calculator, it might just say 508 divided by 7, or it'll give you the decimal, 72.57, etc. If it gives you a decimal, then it is not divisible.